Okay, you guys are awesome. You're hanging in there with me. You have, I think, 2 more problems to go. Okay, so the first problem here is a word problem, and it's on velocity. So our warm-up yesterday was also on velocity, and I read some of you guys' comments, and a lot of you guys had questions as far as how did I get this equation? Is it the only one that we can use? And what do the variables stand for? So to answer your question, actually you can use more than one function. There's lots of functions that we can use that follow a quadratic model. And one of the first things that I want to point out to you is that on this velocity problem, we have h of t is equal to negative 16t squared plus v o t plus ho, okay? And the vo or v0 just really means initial velocity, okay? And the ho means initial height. So yesterday when I asked you to ignore Martha's height when she kicked the baseball or threw the baseball, that means that her initial height was 0. So when we put a plus 0 here, that's why the initial height went away. But this time I'm going to ask you guys to go to the next level and think about, what if I had an initial height of something other than 0? So if you guys watch Dragon Ball Z, there's a Goku. He manages to absorb enough energy to project a spirit bomb towards the ever-strengthening monster Cell. He throws it across the ocean. Okay, so we have Goku. I'm a terrible drawer, okay? And he throws the energy bar or whatever, energy cell, what is it called? Spirit bomb, I guess. And he throws it to the monster over here. Okay, I don't even know what the monster looked like because I don't watch Dragon Ball Z. But anyway, so the projectile is being sent over to the other side, and it's following this function, negative 16t squared plus 36t minus 9. Since I know that my initial velocity is the first number, I know that my initial velocity is 36. And minus 9, that means that the initial height of that guy was negative 9. So maybe he was under the ocean or something. Okay? Alright, so the cell is struck upon impact at the end of the throw. So after he throws the ball, the spirit bomb or whatever, it hits that cell. How long did it take for the spirit bomb to make contact with cell? So if this was an x and y function, or if this was a function graphed on the graph, your x is going to measure time in seconds, and your y-axis is going to measure height in miles. Okay, and the best way to do this is to graph negative 16t squared plus 36t minus 9. So I'm going to exit out of this. You're going to go to, remember I showed you guys how to go to Desmos? You're going to go to Google and just put Desmos. And it pulls up the Desmos graphing calculator. You click on that and you should get something like this. So even if you're at home, you can still follow along with me. You're going to graph negative 16. Instead of a t, I'm going to change it to x. Negative 16x squared plus 36, instead of a t, I'm going to put an x, minus 9. If you notice, the function is graphing itself. You can just use this to see the top. And this is what's modeling. I don't know if I can zoom in. But anyway, so this guy's standing right here. He throws that spirit bomb. It goes up super high. And then eventually it starts to come down to hit cell. Okay, so it says, how long did it take for the spirit bomb to make contact with, that was weird, for it to make contact with cell. So I need to find my 0. And I click on it. And the cool thing is that it finds the 0 for me. So it's 1.964 what? It took 1.964 seconds for the spirit bomb to hit cell. It says, at what time did the spirit bomb reach its maximum height? Okay, so it reached its maximum height at How come it's not giving me? Oh, there it is. 1.125 seconds, and the maximum height that it reached was 11.25 miles. Okay, so you're going to go ahead and complete that answer on your handout. 1.964 seconds, 1.125 seconds at a maximum height of 11.25. It says, despite being struck, Cell receives minimal damage. And so Goku flies to a higher altitude, so his starting point is 35 miles above the ground. So now instead of your initial height being -9, it's now going to change to plus 35. So your function is going to be -16t squared plus, what's the initial velocity? He projects a gamma, whatever that is, wave towards the monster at a velocity of 75 miles per hour. So 75t plus the initial velocity, HO, was 35 miles above the ground. Okay, so in order to graph this, just to let you know, we're going to change it back to f of x. So it's going to say f of x is actually equal to -16x squared plus 75x plus 35. Okay, we're going to graph that function here. -16x squared plus 75x plus 35. Okay, and I still have the previous function, so I'm just going to go ahead and delete it. And this thing is huge. Okay, so he's really angry. He throws like a super bomb, I guess you could say. Alright, so it says, at what time did the blast reach its maximum height? How high was it? So the maximum height happened somewhere up here at 2.3 seconds. The blast reaches its maximum height of 122.89. I don't think I can squeeze both in there, but okay, so at 2.3 seconds, the blast reaches its maximum height of 122.89 miles. Okay, easy, simple. Now you guys know velocity. You know velocity when the height is equal to 0 and when the height is equal to something other than 0. The last two problems, word problems here, are two numbers that have a sum of 15 and a product of 56. What does sum mean? Sum means to add, and product means to multiply. Okay, so what two numbers can I add together to get 15 that gives me a product of 56? Well, this goes back to your CB table. So the question is, what two numbers can I multiply together to get 56 that would add up to 15? So in this case, you need to know your multiplication tables. So of course, 1 times 56, -1 times -56. How about 2? 2 times what gives you 56? 2 times 13? Nope. 13 times... Speaking of not knowing your multiplication table, so 56 divided by 2, 2 goes into 5 twice. So it goes in 28 times. So 2 times 28, -2 times -28. How about 3? Or I know. What about 8 times 7? Doesn't 8 times 7 equal to 56? Yeah, and if I add 8 plus 7 together, don't I get 15? Woohoo! Okay, so I found two numbers that if I add them together, they equal to 15. And if I multiply them together, it equals to 56. Which one is the larger of the two? The larger out of 8 and 7 is 8. Okay, last question. Two numbers have a sum of 13 and a product of 36. Okay, so what numbers can I add together to be equal to 13 so that when I multiply them together, I get 36? So, CB table, what are the factors of 36 so that they add up to 13? Well, I know the factors of 36 are 1 times 36, 2 times 13. Again, I'm doing the same thing. 36 divided by 2 is 18. I don't know, I keep thinking 13. Okay, and then 3 goes into it twice, 12. 4 times 9. 6 times 6 is another one. I kind of ran out of space. Okay, so if I add 36 plus 1, I get 37. 2 plus 18 is 20. 3 plus 12 is 15. And 4 times 9, or 4 plus 9 is 13. Hey! So the two numbers that I can add together, 4 plus 9 gives you 13. If I multiply 4 times 9, you get 36. Alright guys, thank you. You are hanging in there. I'm getting tired, so I imagine you must be getting tired too. I think we have one more video to go. Hang in there.